Lesson 63 is critical number theorem and closed interval theorem. On AP Calculus, theorems are a big thing. When you go into the open-ended questions, being able to state a theorem or use a theorem to back up your reasoning is important. Okay, or just even knowing how, certain theorems work. And this is one of those cases. And in fact, some of this that we're going to talk about, I feel like when you'll see this pop up in some of the multiple choice problems. Okay, this idea. So the first one I'm going to mention is the maximum minimum value existence theorem. It reads, if f is continuous on the closed interval I equals a to b, then f attains a maximum value m and a minimum value m on I. Okay, so if f is continuous, remember continuous is you can put your pencil down, it all connects, right? So if f is continuous on the interval from a to b. So when we say on the interval from a to b, that's saying like this point is at a, and that point is at b. Okay, so it's just a and b are the endpoints of this interval. So if f is continuous on this interval, then f, the function, attains a maximum value, capital N, and a minimum value, lowercase m, on this interval. So all it's saying is that if you've got this drawing on this certain interval, somewhere there is a max and somewhere there is a min. It just guarantees the existence. And if you think about it, to me it makes sense, right? You draw something, there's got to be a high point, there's got to be a low point. And that's what this is saying. Okay? So that is your maximum minimum value existence theorem. Okay. Continuing. Critical number theorem. And, oh wait, do I want to say anything? Okay.
Do the dots count? Like, would the dot be the minimum, or would it be the hill inside of it?
Okay, and so that's a very valid point. Actually, what I was just debating if I wanted to address now or read this and then address. But because it is a closed interval where those are brackets, that means the endpoints are included. And that means the endpoints could possibly be your min and or max. So like in this case, yeah, we see a max here. But then if this endpoint is higher, then that endpoint is going to be the overall max. Same thing here. I see a minimum here, but if there's an endpoint that ends lower, that can count as your minimum. And because part of what we're going to add in now is when you're looking for maxes and minimums, this is what the next theorem talks about. When you're looking for maximums and minimums, it's still take the derivative, set the derivative equal to 0, and you'll come up with your critical points. But besides checking critical points, we'll also be checking endpoints. And that comes up, I know you will see some AP multiple choice questions that focus on that. Where if you don't check the endpoints, guess what? One of the endpoints was the max or min they wanted you to find. So, yeah, good question. So, the critical number theorem says if f is a continuous function on a closed interval I, so same part, and if f attains a max or minimum value at a certain point C. So the max or the min is at C, where C is on the interval. Then C is one of three things. Okay? C could be an endpoint. Okay, so if it's a max or a min, C could be the endpoint. It could be, I'm going to jump down to here to 3, where the derivative equals 0. And that's how we always find our mins and maxes, right? Derivative set equal to 0, that'll find our critical points. Or another one that we haven't really talked about is the derivative does not exist. And when you get a derivative that does not exist, like for instance 0 in the denominator or something like that, but the derivative does not exist, what it is it creates a hard point. So like normally, like here, these are just soft curves, right? And I could have a tangent line to find the slope of for my derivative. If it's a hard or sharp point, then the derivative does not exist. Okay, so if it comes to a point as opposed to just a curve. So, your max or min value. It could be an endpoint. So that's the new part today. We have to check our endpoints. It could be a place where the derivative does not exist, or it could be a place where the derivative equals 0, which, as I said, are your critical numbers. Okay? So you'll notice right down below it says, to find maximum, minimum values over an interval. It says we have to find critical numbers and check those, and what else do we have to check? Endpoints, to see which ones are the maximums and which ones are the minimums. Okay? So in other words, if you have an interval that has endpoints, you can't forget the endpoints. Ready to try one? The directions are, find the maximum and minimum values of f of x equals the given function on the interval -2 to 4. Now, officially, when it says find the maximum and minimum values, realize they are looking for y coordinates. If they want where the max or min is located, they're looking for x coordinates. If they want the max or min values, those are y coordinates. Okay? So, in order to find max and min values, what have we done before today? We have found what? The derivative. So we're still going to find the derivative. So derivative of f of x. Derivative of 2x cubed. And we're going to multiply that 3 by 2 and make it 6x squared. Minus derivative of 3x squared. 6x. Minus derivative of 12x. Plus derivative of 1. Nothing. Okay, so in order to find our critical numbers, we're going to take our derivative and set it equal to 0. What do you notice about this derivative? Yeah, I'm going to factor out a 6 as I go. So it's 6 times x squared minus x minus 2 equals 0.
Can we factor that?
Yeah, we're sure going to try.
Yeah, -2 and 1.
In other words, you should always try. I can't say that it always factors, but so we should always try.
-2 and 1.
X squared breaks up into x and x, multiplying to be -2, adding to be -1. -2, positive 1.
So x equals 0, 2.
I agree with 2 of the 3 of those. Why not 0?
There's no x.
6 is just a constant.
Oh.
In this situation, 6 means absolutely nothing. If it was 6x, then I would be all for your 0.
Okay.
There'd have to be a variable included.
So it's just 2 and -1 then?
Yep. So x equals 2 and -1. These are my what? Critical points. So, we just found those critical points right there, yes? We have critical points at x equals 2, -1. And what else should we consider critical points that we're going to have to check? -2 and 4 because those are your endpoints. So I went from having 2 values to now having 4 because we have to think about the endpoints. How do I determine where my min is and where my max is? Plug it in, right? You're trying to plug these values in to what equation? The original equation, kind of like you guys had on that test problem you just looked at, right? Plugging into the original equation, trying to see where's the highest value, where's the lowest value. So I need to find out what f of 2 is, f of -1 is, f of -2 is, and f of 4 is. Notice I wrote f, not f prime, so that does remind you you're plugging into the original. 2 to the third is 8, times 2 is 16, minus 12, so 16 minus 12 is 4, minus 24 is negative 20, plus 1, negative 19. And it's not that you couldn't use a calculator, you know. I mean, it just comes down to on an AP test, do you have or not have the calculator on this problem? This is a problem that could be done without the calculator, definitely though. Okay, so I could definitely see them putting this type of problem on a non-calculator portion. If we put in negative 1, becomes negative 2, minus 3 is negative 5, plus 12 is 7, plus 1 is 8. Correct me if I do some wrong math. Let's see, negative 2, negative 16, minus 12, so negative 28, plus 24, negative 4, plus 1, negative 3, I think, and 4. Ugh, that one's hard to do in my head. 4 to the third, times 4 is 16, times 4 is 64, times 2, I'm at 128, minus 48. 128 minus 48 is 88. Minus 48 is, I messed that up.
28 minus 40 is
8, oh, there's where I messed it. Okay, thank you. 80 minus 48, I'll get there. 32 plus 1, 33. And honestly, on an AP test, I would probably write those pieces out. I wouldn't try and do that all in my head. Okay. So, question is, we'll find your max and min values. What are my max and min values?
2 and 4.
Okay. I'm going to get technical here, and I'm going to disagree.
Okay. Why?
Technicality.
You need a point on it.
2 and 4 are not my max and min values. That's where my max and min values are located. As I said, I'm getting technical.
No, I need it.
Okay? I mean, you guys, I have to tell you at some point. So, technically, my minimum is located at 2, but what is my minimum? Negative 19. My maximum is located at 4, but what is that max? Did I make my point? I have to, you know, I'll be honest, I'm not good at always pointing that out. So, okay, so min value was negative 19. Max value is 33. And I'll be honest, I don't know, it's to your advantage in a way. If you tell me your min is 2, negative 19, and your max is 433, I'm going to count it right. On an AP test, they might still count that right, but if you just give the 2 and 4, I don't know that they would. Does that make sense?
Yeah.
If it's multiple choice, and they're saying, what is the max? It's going to say 33. Could they throw the 4 in there to confuse you? Wouldn't surprise me, right? So, okay. Moving on. A 10-inch long string is to be cut into 2 pieces. One of the pieces will be bent to form a square, and the other piece will be formed into a circle. Find where the string should be cut to maximize the combined area of the circle and square. Okay. There's some work in this one, I'll tell you up front. We have a 10-inch long string. So, here's my 10-inch long string. It goes from 0 to 10. You just can't see it. I promise it does. Okay, so there's my string. It goes from 0 to 10. And what's being done? It's being cut into 2 pieces. Here's me cutting it into 2 pieces. One's going to form a square, the other's going to form a circle. And I don't know that it matters. I'm going to go with what I've done. So I'm going to pretend this piece forms a circle and this piece forms a square. Now, to get started, we need something to call these. So one of my pieces, I'm going to call x. Because the idea is I'm going to have to write an equation that's all in terms of one variable. If I call this piece x, how can I use x to name the other piece? No. Using this same x, if the whole string is 10,
10 minus x.
and I name this piece x, so if I chop off x, the remaining piece is 10 minus x. Okay. Now, we are trying to, the strings are going to, what's the word I want to say here? They're going to form the circle and the square, yes? So what are the strings going to take the place of? If it's forming the circle and forming the square, it's the perimeter, yes? What do you know about perimeter of a square? Okay, 2L plus 2W, except in a square, it's 4 of something. We usually say S for a side, so I'm going to use 4S for the perimeter of the square. What about the perimeter of a circle? What is perimeter of a circle? Circumference, right? Distance around a circle, circumference. What's the formula for a circumference? There's two of them, depending if you use R or D. I'm going to use R. That's the one that's not the area. I would tell you, but you guys are determined to find it. It looks like down here. I would think it's in there somewhere, but I don't know where. So. There you go. Yep. That's what I'm looking for. And technically you could say pi times diameter, but I want R here. Okay? Now, what I'm going to do with each of these. I drew the circle over here on the side that is x. So I'm going to take my circle formula and set it equal to x. So I'm going to say 2 pi r equals x. We are? Yep. The perimeter is 4s, and it's going to equal 10 minus x. Now the idea is I'm going to need to write an area formula for area of the circle and area of the square. But I need it all in terms of one variable. So I can't have an R in there for the circle and an S in there for the square. I'm going to need it all in terms of x. So what I'm going to do here is I'm going to solve both of these so that they are in terms of x. And then I'll show you what we're going to do with them in a moment. So 2 pi r equals x. Can you solve that for r? If we solve that for r, it's going to be r equals what? X over 2 pi. Just hold on to that. We'll use it in a moment. If I solve this other one for s, we're going to have s equals 10 minus x over 4. And I'm going to leave it like that for right now. Okay. Now, the whole idea is that we are maximizing combined area. What do you know about area of a circle? There's that pi r squared. What do you know about area of a square? If we're using that s, it's s times s. If I try and combine this area, pi r squared plus s squared, I'm talking two different variables. And we don't want to talk two different variables. So this is where I'm going to use what I have right above and sub it in. So if it's pi times r squared, I'm going to say pi times, and for r, I'm going to say x over 2 pi quantity squared. If we clean that up a little bit, what happens here? X has to become x squared, right? If you square the denominator, 2 pi squared, well, 2 squared is 4. Pi times pi is just pi squared. But what do you also have out here? A pi on top. A pi on top can cancel with 1 pi on bottom. So when I write this, and again, I know where I'm going with this, I'm kind of prepping you. I'm going to put my coefficients out front. So coefficients-wise, in the denominator, I'm going to have a 4 and a pi, and then just a 1, and I'm going to say that this is times x squared. So 1 over 4 pi x squared. And I could have done that without the multiplication dot, but I put it there without thinking. That's the area for the circle. Same type thing for area of the square. It's a equals s squared, except what are we using for s? 10 minus x over 4, quantity squared. If we square this fraction, numerator times numerator, denominator times denominator, right? So if we get the easy one out of the way, and the denominator, 4 squared is 16. The numerator, 10 minus x, quantity squared, which means when you do 10 minus x times 10 minus x, we have to FOIL. 10 times 10 is 100. 10 times minus 10, no. 10 times minus x, minus 10x. Another minus 10x is going to be minus 20x. Minus x times minus x, plus x squared. Now, I'm out of room right there. When I write my formula here in a moment, I don't want to have to think about taking derivatives of that, so I am going to break it into 3 terms. But we're trying to combine area, yes? Area of a circle, area of a square. To combine them, we're going to add them. So, I'm going to go up here, and I'm writing my area formula. My area formula. I'm going to get the first one, the other one first. So the 1 over 4 pi x squared plus. Now I'm going to do the, well, Carly started to say 100 over 16. If you want to go ahead and reduce that, divide by 4, and it's 25 over 4 minus 20x over 16, which both divide by 4. So that's minus 5/4 x plus x squared over 16. I'm going to say 1/16 x squared. How do I maximize? I have to take the derivative and set equal to 0. And keep in mind, we're going to have to check our critical points and any endpoints. Okay, so I tried to set this up so we are good to take a derivative here. As good as it gets, at least. Should I zoom in on this part so you can see this part a little bit? 1 over 4 pi x squared. The derivative says what? multiply by the 2. 2 over 4 pi can really reduce to 1 over 2 pi and then x. Derivative of 25 fourths, 0. Derivative of minus 5 fourths x, minus 5 fourths, plus derivative of 1/16 x squared. Multiply the 2. 2 times 1/16 is 2/16, which reduces to 1/8 x. Officially, we need to, what do you do once you get the derivative? Set it equal to 0. Notice I have 2 terms with x, 1 term without. So that means I'm going to keep my x's where they are and move the other term over. 1 over 2 pi x plus 1/8 x equals, if I add the 5 fourths over, equals 5 fourths. How do I solve for x here? Do you know?
I don't.
A common bottom of 8 pi.
Oh. Is that what you do?
My brain was thinking a slightly different way, but yes, we'll meet in the end. So yes, we can say yes to that. In my brain, okay, so I get it. Wade's going for a common denominator, yes?
Yeah.
And it looks different in my brain, but these are both x to the first, yes? So can we add those? Yes, you can, okay? You need a common denominator, and that's where he said 8 pi. So let me go with this option. I think I can. If we say common denominator of 8 pi, what do we have to multiply the first fraction by? 4. And so it becomes 4 over 8 pi x plus, what do I have to do on the next fraction? It's, if I want pi, multiply by pi, so it's going to be pi over 8 pi x equals 5 fourths. When you add these together then, denominator is 8 pi. What's 4 plus pi? 4 plus pi. So we're going to have the fraction 4 plus pi all over 8 pi times x, which is the same result I have on my paper.
So the x's don't add it, just is.
You add the coefficients. It's just like saying, okay, what's 2x plus 3x? 2x plus 3x is 5x. You add those coefficients. So we did add the x's by adding those coefficients, and we got that fraction there. Okay?
For some reason, I really seeing it as like a separate thing.
It's like saying that that's like 10x, except my 10 is that fraction. How do I solve for x? Divide by my fraction. Dividing by a fraction is a little bit more neatly done if we multiply by the reciprocal. Keep, change, flip, yes. So when I say this, x is going to be equal to, we already have the 5 fourths, right? Times the reciprocal of this guy, which is 8 pi over 4 plus pi. Now, that's not going to clean up a whole lot, is it? Okay. It does look like I went a decimal route here. If I go a decimal route, can I save us time and tell you what I have? 4.3990. We could go either way with it, but I went decimals. Just because it gets kind of ugly. And okay, so what is that 4.3990? Now,
That's where you cut the string.
that's a possible place to cut the string at. It is a critical point.
Oh, so 0 to 10 also a critical point.
It is. We need to consider not just any critical points. Like before today, we would have just said, oh, we cut the string at 4.39. That's our only critical point. But there are endpoints, yes. This string is not infinite in length. This string is, I can't remember what the opposite of infinite is, but finite. There you go. Finite in length.
What is fun?
Ends. Yeah, the opposite of infinite. It has endpoints. And so what we need to do is we need to check 4.3990 along with the endpoints. What are the endpoints? Left endpoint is length 0. Right endpoint is length 10. So we're going to need to find, what A of 0 is, what A of 4.3990 is, and what A of 10 is. Which formula do I plug those into? The original. Okay. Well, you can do 0 without a whole lot of work. If we plug 0 in, it's going to be 25/4, which I'm going to go and remind you that decimal is 6.25. I feel like I'm running short on time, so I'm going to tell you then. Am I okay to just tell you guys numbers? Let's plug it into your calculator. I plug in the 4.3990. I have written down 3.5006. And if I plug in 10, 7.9577.
The original equation, not the derivative.
Correct. Original equation. We were trying to maximize. Which one is my max? 7.9557 is my max value. The question was find where the string should be cut. At what point should the string be cut?
You don't cut.
Okay. If you want to give the official answer, at 10 inches, which 10 inches is the end of the string, you don't cut. Okay. This string, you don't cut it. If you look back at the original picture, the original X was your circle. So that means you should use the whole string for the circle. So I'm going to say at 10 inches, but understanding that means, yeah, you should not cut it. Okay? Should not cut the string. Use for circle.
Oh, so this was kind of a trick question.
Yes. I'm waiting for someone to say it. We did all that work to find that out. That's usually the response I get.
I was thinking.
We still have 2 more to do. I thought we had 1 more. Okay, gotta move. One of those days, I guess. Do we have what we need from this page? Example 3. Find the max and min values of f on the interval -2, 3, where f of x equals x to the 2/3. Similar to the first problem we did. Of course, there'll be a twist. We'll get to that. But similar to the first problem we did, which was we need to start by finding the derivative. So if f of x equals x to the 2/3, what's f prime of x? 2/3, because you multiply that 2/3 out front, x, subtract 1, so 2/3 minus 1, so 2/3 minus 3/3 is -1/3. And then you take said derivative and set it equal to 0. Now, as I said equal to 0, I'm going to write this in a different form. 2/3 is a fraction. What do you know about negative 1/3 as that power? Okay, so the negative will take it to the denominator, and the 1/3 is a cube root. That's your algebra 2. My kids are quizzing over it tomorrow. Of course, the password's incorrect. Sorry. Time is working against me. So if we think about it that way, x to the negative 1/3 is the cube root of x in the denominator. 2/3 is a fraction, so that means 2 stays on top, 3 goes in the denominator. Inspect this. When does this fraction equal 0? Can x in the denominator equal 0? No. It's not. The only way this fraction could equal 0 is if 0 can be in the numerator. Can 0 ever be in the numerator? No, it's a 2 in the numerator. So this fraction cannot equal 0. Okay? When can it not equal 0? When what is in the denominator? Well, but what's going to make this fraction undefined is what I'm asking, I guess. But what makes the fraction undefined? What x value cannot work here? You can't have 0 in the denominator. I'm not asking this right, obviously. Okay? We can't have 0 in the denominator. So what I'm trying to lead you to, unsuccessfully, sorry, is that the derivative at 0 does not exist because you can't put 0 in the denominator of a fraction. And that's what would be happening here. So for that purpose, it's not a critical point as in what we typically say. It's a point where the derivative does not equal 0. Or does not exist, I should say. So what do we have to check? Yeah, we have to check our endpoints again. And then we have to check the one we just came up with. So you're checking f of 0, f of negative 2, and f of 3. If you put 0 into the original problem, 0 to the 2/3 is 0. I have decimals written down, so I must have used my calculator. If I put in negative 2 to the 2/3, 1.5874. If I put in 3, 2.0801. What was my question? Max and min values. Where's my min?
At 0.
At 0. Where's my max?
2.08.
The max is that 2.0801 number, and it's happening at 3. What was the question? Find the max and min values. So, min value is 0. Max value is that 2.0801 number. Okay. Example 4. They give us a bunch of information. And, okay, I'm like, it doesn't tell me what to do. What we're going to be doing, and I'm going to write it in right here, is find the values of x for which f attains max and min values. That's what we're going to be doing here. Now, they gave us a bunch of information. It is important to notice, they told us up front that this is continuous. If they don't tell us this is continuous, it changes everything. Because you can't just assume. There has to be something telling you that. On the closed interval from -2 to 4. They also tell me that f of -2 equals 2. So I'm just going to write this information kind of by my table here. And f of -1 equals -1. And f of 4 equals 5. And then furthermore on the table, the f prime and f double prime have the properties indicated in the table. Okay. Give you a moment to catch up. Oh, okay. I just caught it also. -2 to -2 doesn't make sense, guys. This is supposed to say -2 to -1.
Is that a negative 5 at the end or is that just 5?
F of 4 equals 5. It's what they gave me in the problem. I didn't come up with that out of nowhere. It was given right here.
Oh.
Everything, these 3 pink things I wrote up above, that's not magic. That was provided in the directions. Okay? Now, what does a first derivative tell you about a graph? If a first derivative is negative, what is the graph doing? It is decreasing. So we know from -2 to -1 that our graph is decreasing. We won't worry about the undefined right now. When my first derivative is positive over here, what's it going to be doing in this interval? First derivative says increasing. I'll come back to 0 again. First derivative positive over here says it is increasing. Officially, these points where it's 0 and undefined, they're critical points of some point. Maybe it's a min, maybe it's a max, maybe it's an inflection point. Okay, what's the second derivative tell me? First derivative is increasing or decreasing. Second derivative is concavity. So negative second derivative says that this is concave down. Another negative section here, so it's concave down. And then the last one is positive, and that is, there's your concave up. Now, right here, because my graph, okay, where x equals 2, min, max, inflection point. My graph is increasing and then increasing again. It can't be a min or a max, so it has to be an inflection point. Because you can't go from increasing to increasing and have a min or a max. Just think logically there. This undefined says that it is what I mentioned this earlier, a hard point. Now, we're going to sketch this graph together. So when you get ready, draw yourself a little set of axes down below. Set it up so you can go at least 4 to the right. Think at least 5 up. At least 2 left. And at least 1 down. Does that help if I tell you those numbers? Not that you can't go farther, but that's kind of the minimum requirements. We were given some points, yes? F of -2 equals 2. That means that there is a point where? At, that's the ordered pair, -2, 2. That's what they're telling you there. That is the ordered pair, negative 2, 2. So where else do I have ordered pairs? When it says f of negative 1 equals negative 1, that is the ordered pair, negative 1, negative 1. So just make these points. And they told me f of 4 equals 5, so that is the ordered pair, 4, 5. No, that's a derivative is equal to 0. That's not an ordered pair necessarily. Okay, so in my interval from negative 2 to negative 1, my graph is what? Decreasing, going down, which that makes sense, doesn't it? And it's concave down, which means it is kind of, does it make sense if it's kind of bowled that way? So that my concavity is down. I said at negative 1, it's a hard point. From negative 1 to 2, which is going to happen over in here, right? I don't have that. It's increasing but concave down. So that means my graph is increasing, but it's facing down. At 2, I have an inflection point, and I'm still increasing, but now my graph is more concave up. I know that's quick. I'm sorry. Does that make a little bit of sense? Okay. Well, we did figure out here we've got a min at x equals negative 1 and a max at 4. So, ask me again tomorrow if you want me to talk about that one a little bit more. I think so, but I can't. It's not like I didn't look at the homework today to know for sure. Does that make sense? I feel like there's one in the homework. I mean, that's definitely, you see those kind of charts in AP and stuff. So, okay, guys, thanks for bearing with me.